Hello everyone, I hope you are doing very well. So welcome to this class. In this class, we are going to discuss the NCERT exercise questions of this chapter, that is chemical reaction and equation. You know very well this chapter is important according to exam point of view. And in this chapter, if I will go with the summary, right, quick summary, you know very well in this chapter we had introduced what is a chemical reaction, right? Now you are very much aware about that what is a chemical reaction. You know very well a chemical reaction is always accompanied by a chemical change. Okay, what is the physical change, what is a chemical change, you know that very well. Apart from this, after suppose a chemical reaction is happening, like if iron piece is here, if iron piece is here and placed in atmosphere, right, where oxygen and moisture both things are there, so iron piece will get rusted. It means there will be deposition of reddish brown color layer. There will be a deposition of reddish brown color layer on the surface of iron objects, and that is nothing, that is known as rust. And this phenomena is known as rusting. Rusting is nothing, rust is nothing, that is what, that is hydrated ferric oxide, Fe2O3.xH2. And rusting is a lead to corrosion. Corrosion, like if I am saying corrosion is the decay of metal due to the attack of atmospheric gases. In case of iron, it is named as rusting, or in case of copper and silver, it is named as tarnishing. In case of iron, there is a reddish brown color layer deposition. There is a deposition of reddish brown color layer. This is reddish brown powder, reddish brown color layer. And in case of silver, it will be copper. Oh, sorry, it will be black. And in case of copper, it will be green color. It will be green color layer. Okay. In case of copper and silver, this corrosion is named as tarnishing. Tarnish. Let's come back. Suppose I am saying our reaction is happening, right? Okay, like iron is reacting with water and moisture, and it is forming this reddish brown color layer, which is nothing, that is rust. So iron is forming rust. So due to the attack of atmospheric gases and due to the attack of this water and moisture, so this is orally. I am saying this orally. How can I write this particular reaction on paper? How can I write? So chemical reaction representation on paper. We can represent a chemical reaction on paper in two ways. The one way is word equation, another way is like chemical equation, or you can say symbolic form. Symbolic form. The word equation is not very much informative, but symbolic form is very much informative, you know very well. Like the word equation is like hydrogen plus water hydrogen plus oxygen gives water. Hydrogen plus oxygen gives water. We don't know like how many amount of hydrogen, how many amount of oxygens are reacting with each other to give what amount of water. That means you can see this is not very much informative. It is not providing what, it is not providing the complete information. But symbolic form, if I will write and I will balance this equation, because you know very well every reaction should be balanced, every equation should be balanced, because every reaction is following the law of conservation of mass. Whatever the mass whatever the mass you are taking, you will get the same mass in the product side. It means the reactants and products, the masses, total mass of the reactants and product side will be equal according to law of conservation of mass. Or in simple words, you can say matter can neither be created nor be destroyed. But in a balanced chemical equation, you can say the total number of atoms of each and every element in the reactant side and product side are equal. So this is about the symbolic form. So H2 plus O2 gives H2O. This is not a balanced chemical equation. This is a skeletal equation. If you want to balance, how can you check? You can check the number of atoms of each and every element in the reactant side and product side. If the number of atoms of each and every element in the reactant side and product side are not equal, so that will be what? That will be the, what I can say, that will be unbalanced chemical equation or skeletal chemical equation. If you got any skeletal chemical equation and the question is asking like convert this equation into balanced chemical equation, so you have to follow the hit and trial method, right? You can balance that particular equation, you can follow certain steps. First of all, write the correct skeletal equation, make a tabular form, write the number of atoms of each and every element in the reactant side and product side, then check and start from the start from that particular, what I can say, that particular element, that particular compound which contains more number of atoms. Okay, that particular compounds which contain more number of atoms, start from that, and then start balancing, make a hit, check it is balanced or not, then again make a hit, check it is balanced or not, and then you will get that you will get the complete balanced chemical equation. A complete balanced chemical equation or symbolic form is more informative because it is providing the information regarding like what amount of reactants are reacting to give how much amount of products, right? So suppose x amount of reactants are reacting to give y amounts of products. So this is clear, this is very clarified equation. So symbolic form, if I will balance this, so you have to put 2 here and you have to put 2 here. Now this equation is completely balanced. Now it is clear from this equation that 2H2, that means 2 molecules of H2 is reacting with 1 molecule of HO2, gives 2 molecules of H2. Or you can say in terms of mole, like 2 mole of H2 is reacting with 1 mole of O2 is giving 2 mole of H2. Also you can say the hydrogen mass is 1. So for 2 hydrogen it is 2. For 4 hydrogen it is 4. So 4 gram hydrogen is reacting with 1 oxygen 16, 2 oxygen 32. 32 gram of oxygen to give definitely 36 gram of what? Water. Definitely 36 gram of water. And also you can say 4 gram of 4 gram per mole of hydrogen, like that. In terms of, like, you can say different terms, but this equation is providing complete information, that is a symbolic form. I hope you got each and every point here, and you got how to balance, and you know what is a balanced chemical equation, and you know what is an unbalanced chemical equation. After this portion, we had moved what base we had moved to the types of chemical reaction, towards the types of chemical reaction. You know, here are certain types of chemical reactions, like first is combination reaction, next is decomposition reaction, next is displacement reaction, next is double displacement reaction, apart from this redox reaction also, or some basic terms like oxidation in redox reaction, like reduction, oxidation reduction, oxidizing agent, reducing agent, then some another terms like corrosion, and the last term is like rancidity. So these are some important topics from this particular chapter. I hope you know each and every topic. Now I want to discuss the NCERT exercise questions. I hope you are ready. So now let's begin with the NCERT exercise questions. I hope all of you are ready. And whenever you are just watching these NCERT exercise question sessions, so what you have to do, what I want to give you as an advice, so you can take your notebook and pen. Whatever the question I am just showing you, you can first of all solve that questions by yourself. Then you can check the answer and solutions. So let's begin with the question. You can see the question is here. Explain the following in terms of gain or loss of oxygen with two examples each. This is very simple and easy term, that is oxidation and reduction. You know very well what is oxidation, right? In the next grade now, you will learn so many other definitions of oxidation and reduction in different terms. Like for your grade, if I'm telling you oxidation is nothing, that is addition of oxygen, addition of oxygen and removal of hydrogen. In terms of hydrogen, you can say removal of hydrogen. In terms of electron, if I want to say loss of electron, is known as oxidation. Let's understand only these three definitions of oxidation. Similarly, reduction is opposite. So you can say addition of what? Hydrogen. Removal of oxygen. And gain of electron is known as reduction. Gain of electron is named as reduction. So this is about oxidation reduction. The reactions in which oxidation and reduction oxidation and reduction reactions are happening simultaneously, those reactions are named as redox reaction. Those reactions are named as redox reaction. So this is about the redox. So let's understand, explain the following in terms of gain or loss of oxygen. So gain of oxygen, oxidation means addition of oxygen, reduction means removal of oxygen. So addition of oxygen means oxidation, or removal of oxygen means addition, means you can say gain of oxygen, or removal of oxygen means, or you can say loss of oxygen. Loss of oxygen means reduction. I hope you got this concept. Let's understand the two examples of each reaction. You can see like CO2, which is carbon dioxide. There is an addition of H2, right? So CO2 plus H2, they are reacting with each other. You will get CO plus H2O, right? Carbon monoxide plus water. So addition of oxygen is known as oxidation. Addition of oxygen. So you can see CO2 is undergoing CO. That means removal of oxygen. And H2 to H2O, addition of oxygen. Here you can understand a very simple term. If addition of oxygen is taking place, definitely this is named as oxidation. And the substance that is getting oxidized, the substance that is getting oxidized, which is H2 here. So H2 is converting itself into H2O. So if H2 is converting into H2O, so there is an addition of oxygen is taking place here, and this is named as oxidation. So you can say, if H2O is gaining an oxygen from where? From CO2. So CO2 is undergoing reduction. So removal of oxygen means reduction, and the substance that is undergoing reduction is named as oxidizing agents, because it is releasing its oxygen. That's why H2 is getting oxygen. And the substance that is getting oxidized, it means H2, is named as reducing agent, because H2 is accepting this oxygen. That's why CO2 is what I can say, releasing its oxygen. I hope you are getting the concepts. What is an oxidizing agent and what is a reducing agents? So oxidizing agents, reducing agents, reduction and oxidation, these four terms are different. Oxidation, addition of oxygen, removal of hydrogen, loss of electron is known as oxidation. Reduction, addition of hydrogen, removal of oxygen, gain of electron is known as reduction. What is oxidizing agent? The substance, the species that is undergoing, because you know very well, oxidizing agent, so which oxidize others and reduce itself. So the substance and the species that undergo reduction and oxidize others is known as itself undergo reduction and oxidizing others, so it is known as oxidizing agents. Itself undergo oxidation and reducing others is known as reducing agents, is known as reducing agent. If reducing others, reducing agent, oxidizing others, oxidizing agents. Another example you can take like 2Cu plus O2. So here is also, so in this particular reaction, CO2 plus H2 gives CO, carbon monoxide plus water. In this particular reaction, both reactions are happening. That means oxidation and reduction. So this is an example of redox reaction also. This is an example of redox reaction also. You can see another thing. 2Cu plus O2 gives 2Co. This is an example of oxidation. This is an example of oxidation reaction. Gain of oxygen is taking place here. Now you can see the next one is H2 is oxidized to H2O in the first equation, and Cu is oxidized to CuO in the second one. Reduction is the loss of oxygen, or you can say gain of hydrogen, but the question is asking in terms of oxygen only, so you can write loss of oxygen. For example, CO2 plus H2O, so there will be removal of oxygen from where? CO2 plus H2O gives CO plus H2O, so definitely CO2 is undergoing reduction. So removal of oxygen is known as reduction. So it is acting as a oxidizing agent. Next is CuO plus H2 gives Cu plus H2O. CuO, copper oxide plus H2, upon heating it will form Cu plus H2O. So CuO is undergoing reduction. CuO is undergoing reduction. It means loss of oxygen is taking place here. In this equation, first part CO2 is reduced to CO, and in equation second CuO is reduced to copper. Copper oxide is reduced to copper. I hope you are very much clear about that. The next question is a shiny brown colored element X. Okay, this is the element X. Upon heating, we are heating it. It becomes black in color. Okay, it becomes black in color. Name the element X and the black color compound formed. So if you are heating, definitely it is reacting with oxygen because heating takes place in presence of oxygen. So if X plus O2 gives its oxide of X, which is black in color, definitely you know that copper oxide is black in color. Definitely you know that copper oxide is black in color. So the shiny brown color metal, and brown color is of copper metal. So copper is that particular X element. So let's understand X is copper and the black colored compound formed is copper oxide. The equation of the reaction involved on heating is given below. 2Cu plus O2 gives 2Co. Addition of oxygen is taking place here. So copper is undergoing oxidation. Copper is undergoing oxidation. Okay, so this is an example of what? Oxidation reaction. And the copper is shiny brown in color. Cu is shiny brown in color and copper oxide is black in color. This copper oxide CuO, which is formed after the reaction or after the heating of copper in presence of oxygen, we will get copper oxide, which is CuO, which is black in color, right? So let's move to the next question. Why do we apply paint on iron articles? As I told you already, the term corrosion. As I told you already, the term corrosion. If you know the corrosion, so definitely you know why do we apply paint on iron articles. Suppose this is the iron object. Let's suppose this is an iron object, and if I will put a protective layer here, if I will put a protective layer here, I don't know this is a paint or this is whatever, but a protective layer is put. What I can say, a protective layer coating is coated on the surface of iron object, right? So what will happen? The attack of atmospheric gases like moisture and oxygen will not attack directly to the surface of iron objects. So definitely what happen? Iron objects will not rusted, will not get rusted. Okay, so do avoid rusting, right? To avoid rusting, or simply you can say to avoid corrosion. So let's understand, iron articles are painted because it prevents them from rusting. To prevent rusting, we can say. Okay, avoid is not a perfect word. You can write prevent. So iron articles painted because it prevents them from rusting. Rusting is nothing, that is the formation of rust due to the attack of atmospheric gases like moisture and oxygen on the surface of iron metal. When painted, the contact of iron articles from moisture and air is cut off. If the attack is cut off, if the moisture and air is cut off and they are not comes directly in the contact of iron articles, so definitely it will not undergo in rusting. So hence rusting is prevented. Their presence is essentially for rusting to take place, because their presence is very much essential for rusting to take place. And during rusting, the formation of rust will take place, and rust is nothing that is hydrated ferric oxide, which is nothing that is Fe2O3.XH2O. You can see the reaction. I will show you the reaction as well. You can see the reaction is I will show you the reaction. What is the reaction here? Like Fe plus H2O in presence of oxygen, it will form Fe2O3.XH2O. Like this you can write. Okay, like this you can write. First Fe plus O2 gives Fe2O3, and when it comes in presence of H2O, it will form Fe2O3.XH2O. Next is oil and fat containing food items are flushed with nitrogen. Why? You know chips packets. Sometimes you are surprised, like the chips packet is very large, and but the amount of chips is very less. Why? And the packet are very fluffy. The packets are very fluffy and they are full of air, right? So small kids are like, we need chips apart from this air, but you know this air is very important, right? This air is nothing that is nitrogen, and this oil and fat containing processed food items like chips, namkeens, they are flushed with this nitrogen gas. Why? Because nitrogen is not very much reactive and it is inert in nature. It is inert, it is not reactive, and because the food that is inside that packet, right? That is inside the packet is processed, like you can say oil and fat containing. And oil and fat containing food items, when comes in oxygen, they will undergo oxidation. Due to this oxidation, the smell and what I can say, the smell and taste of that food, the smell and taste of that particular food will get changed. And due to the change in smell and taste, the food will become rancid. That will be uncomfortable for our health. It means if we intake that food, it will be not healthy for us, it will be not healthy for us. So that's why oil and fat containing food items are flushed with nitrogen, because it is less reactive, to avoid this oxidation process, and they are tightly packed. And also there is an expiry date. That's why always it is advised to you, whenever you are taking any type of product, whenever you are taking any type of product which is oil and fat containing, like chips, namkeens, and etc., so definitely see the expiry date. After the expiry date, the smell and taste of that food will change, and you and that food, that rancid food, the food will become rancid, and that rancid food is not good for our health. Okay, that rancid food is not good for our health. And this process of becoming rancid food is known as rancidity. So you can see the answer: nitrogen is an inert gas which is not reactive and does not easily react with their substances. On the other hand, if oxygen reacts with food, if oxygen is there, so it will react with food substances and make them rancid. Rancid means the smell of that food will get changed, the smell and taste of that food will get changed. Thus, bags used in packing food items are flushed with nitrogen gas to remove oxygen inside the pack. When oxygen is not present inside the pack, rancidity of oil and fat containing food items is avoided, and the food will not get rancid. The food will not get rancid, and you can take that food for some time till the expiry date. Next question is, explain the following terms with one example of each: corrosion and rancidity. You know what is and what are antioxidants? First of all, I want to tell you what are antioxidants. To avoid rancidity, we can use antioxidants. Like nitrogen is also acting as an antioxidant because it is preventing the oxidation. It is preventing the oxidation. Apart from this, BHA and BHT, these are some famous antioxidants that are used, like butylated hydroxyanisole and butylated hydroxytoluene. Right? These are some examples of antioxidants. Let's understand this term corrosion. Corrosion, in a simple word, we can say corrosion is nothing that is the decay or deterioration of metal due to the attack of atmospheric gases, and there will be formation of some other substances on the surface of metal, right? And that is a decay of metal. Actually, that is a decay of metal. To avoid corrosion, to prevent corrosion, we can use certain methods, like in iron objects, on the surface of iron objects, we can use grease, right? And we can use paints. We can do the galvanization process, and etc. Another things are there. Apart from this, rancidity is nothing that is oil and you can say like oil and fat containing food items will get rancid due to the oxidation process. It means the smell and taste of that food will get changed, and that food will not good for our health. So we what I can say, we should not eat the rancid food. The answer of this particular question you can see here. Corrosion is nothing. Corrosion is defined as a process where materials, usually metals, deteriorate as a result of chemical reaction with air, moisture, and chemicals. You can say atmospheric gases, etc. For example, iron, in the presence of moisture, you can see moisture reacts with oxygen to form hydrated iron oxide. You can see hydrated iron oxide, or you can say hydrated ferric oxide. 4Fe plus 3O2 plus NH2O, or you can write XH2O. Generally, we can write XH2O gives 2Fe2O3 and XH2O. This is hydrated ferric oxide. This is hydrated iron oxide, or you can say hydrated ferric oxide, because iron is present here in Fe3 plus. Iron is present here in Fe3 plus. I hope you are getting this post. Fe2 plus is ferrous, Fe3 plus is ferric. I hope you got the answer of this particular question. Let's move to the next question. Are you ready? Not next question, the next part of this particular question. So you can see the next part is, but before that, I want to tell you that hydrated iron oxide is named as rust, and having reddish brown color. Rust is a reddish brown color layer, which what I can say, which is formed on the surface of iron metal or iron objects, iron articles, reddish brown color layer. Next is rancidity. And not only rusting is the part of corrosion, corrosion has tarnishing as well, right? Tarnishing in case of copper and silver. Okay, note down this point. In case of copper and silver, this corrosion process is named as tarnishing. And in case of copper, the color of the surface layer will be what? The color of the surface layer will be green, and in case of silver, it will be this. In case of copper, it is due to the formation of copper carbonate, or in case of silver, the color of this black color layer, the color of this layer will be black, and this is due to the formation of silver sulfide. Okay, let's come back to the rancidity. Rancidity is nothing that is the process of oxidation of fats and oils that can be easily noticed. How? By the change in taste and smell is known as rancidity. This process is known as rancidity. If the food becomes rancid, you should not eat that food, that rancid food, because it is not good for our health. It will cause some diseases. For example, the taste and smell of butter changes when kept for long. You know very well. You know very well. This is interesting point. This is an interesting point. Okay. So rancidity can be avoided by what? Rancidity can be avoided by storing food in airtight containers. You have to store food in airtight containers. Sometimes what happens, you go for a shop, right? Suppose you go for a shop, and you can see in shop, so shopkeeper kept some namkeens or items in containers. Okay, and if the container is not properly tighted, right, properly tight, so what can you see? If you will taste that food, it is like a, what I can say, it is like a moisturized. Okay, and also the smell and taste of that food, that chips, that namkeen, get changed. So rancidity can be avoided by storing food in airtight containers. Storing food in refrigerator, if you will decrease the temperature, oxidation will be slow. Adding antioxidants, as I told you already, like BHA, BHT, you can add. This is what? This is butylated hydroxyanisole, and then the lower one is butylated hydroxytolvene. These are antioxidants to avoid this rancidity process. Next is storing food in an environment of nitrogen. Nitrogen is an inert gas. Nitrogen is an inert gas which is not reactive. Not reactive. So to avoid rancidity, we can use this method also. We can use these method also. So rancid food is not good. Again, I'm repeating this point. So this is all about this particular class. I hope you got each and every concepts. Like how can we, what I can say, like how can we write balanced chemical equation? How can we convert unbalanced chemical equation into balanced chemical equation? What are the types of chemical reactions, and what is rancidity, what is corrosion, what are these what are these basic terms, right? And based on them, we had practiced questions from NCERT exercise. So this is all about the solution of NCERT exercise questions. I hope you got each and every concept. Okay, so today whatever we have covered, I told you already. Again, I am repeating this point. You have to revise your concepts, you have to practice. Practice makes you perfect. Okay, before going to any exam, practice, do practice, which is very important. Okay, always make some flowcharts, make some tips, make some your own tips, make some mnemonics, right? And in this particular what I can say, in this particular chapter, the reactivity series, which is also named as activity series, reactivity series, which is also named as activity series, you can learn this activity series or reactivity series by some mnemonics, which is starting from potassium and ending at platinum. So from potassium to platinum, like this, if you are going to left to right, the series is written in book from top to bottom. So if you are moving left to right from potassium to platinum, or you can say like top to bottom from potassium to platinum, the reactivity will decrease. The reactivity will decrease. It means the metal which is above in the reactivity series is more reactive than the lower one. It's more reactive than the lower one. And you know displacement reaction, the answer of displacement reaction, you can tell with the help of this reactivity series. So you should learn this reactivity series. This is very important by some mnemonics, and you can write this reactivity series again and again on paper. So that's why this is important. Okay, so this is all about this particular session. Thank you so much again. We will meet soon in the next class with the next topics. Okay, everyone, thank you. Have a nice day. Take care. Goodbye.